For decades, science fiction has dangled this incredible, almost unbelievable future in front of us. A world where the human mind and artificial intelligence finally become one. But what if I told you that future isn't some far-off dream? What if it's literally starting to happen right now?
Yeah, that's the thing, isn't it? The timeline has just collapsed. Everything we thought was safely tucked away in the pages of a novel is now happening in real labs with real people. The line between us and the machine is blurring way faster than anyone ever predicted. So let's be clear, this is not a what-if scenario anymore. It's a what's next reality. The foundational work for the first true human-AI merge is underway, and really, the biggest question isn't if it's going to happen. It's whether or not we're ready for it.
Okay, so how is any of this even possible, right? Well, this merge isn't just one single breakthrough. Think of it more like a collision of two absolutely mind-blowing fields of science. On one side, you've got brain-computer interfaces, or BCIs. This is all about creating a direct, high-speed connection between our brain and a digital device. And on the other side, we have something, well, something a lot weirder: organoid intelligence. We're talking about literally teaching living brain cells how to process information.
Let's dig into BCIs first. At its core, the idea is kind of beautiful in its simplicity. Every single thought, every memory, every movement you make, it's all just a pattern of electrical signals firing between your neurons. A BCI is basically designed to listen in on that electrical conversation and translate it into a command a computer can actually understand.
And right now, there are two main ways to do this. You've got the really invasive method, like what Neuralink is doing, where a specialized robot surgeon implants these incredibly thin electrode threads deep inside the brain. That gets you a super precise reading. Then you have less invasive methods, like from a company called Precision Neuroscience, which uses a thin film that just rests on the brain's surface. A much, much safer procedure.
And look, this isn't just theory. For people like Noland Arbaugh, one of the very first Neuralink participants who lives with severe paralysis, this technology is completely life-changing. He can now surf the web, play video games, and talk with his friends and family, all just by thinking. It's literally given him his independence back. And the pace of this is just staggering. By late 2025, Neuralink was aiming to have at least 7 trial participants. Now, that number might sound small, but for technology this complex and this new, it signals a kind of acceleration that's forcing everyone to pay attention. This isn't just a one-off experiment anymore. This thing is scaling, and it is scaling fast. Now for that second pillar, and this is where things get really, really wild. Scientists are now literally growing what they call brain organoids. They take human stem cells, and over a few weeks, these cells just assemble themselves into a 3D structure that mimics an early human brain. Now, they're not conscious, they're not self-aware, but they are functional neural networks that can actually learn and remember things. So how does that work? Well, in one famous experiment, scientists taught one of these little organoids to play the video game Pong. They'd send it signals about where the ball was. If the organoid's neural response moved the paddle correctly, they rewarded it with a stable, predictable signal. If it missed, it got pure chaos. And over time, the neurons physically rewired themselves to get better and better at the game, all driven by this fundamental desire for order. It's raw, biological learning in a dish.
So, what's the point of all this? What are we trying to achieve? Well, the goals are absolutely massive, and they basically fall into two huge categories. First, restoring human function, and second, enhancing it way beyond our natural limits.
The most immediate and I think most noble goal is restoration. I mean, this technology could be a lifeline for millions. Imagine giving someone with a spinal cord injury perfect control over a robotic arm, or treating diseases like Parkinson's or epilepsy. Neuralink is even working on a project they call Blind Sight to restore vision by feeding data from a camera directly into the brain's visual cortex.
So that's the first step, and it's an incredible one. But it inevitably leads us to a much bigger and way more controversial question. What happens when we use this incredible power not just to repair what's broken, but to upgrade?
And this is where we step firmly into superhuman territory. I mean, just think about having a flawless, searchable memory that's backed up to the cloud. Or imagine learning a new language in a few hours instead of years. The long-term vision for some of this tech is basically telepathy, the ability to send entire concepts or emotions to another person instantly.
It is the ultimate collaboration of human intuition and machine intelligence. But all of this incredible power forces us to confront some of the most profound and, frankly, some of the most terrifying questions humanity has ever faced. And it's a conversation we absolutely have to have right now. Okay, first and foremost, what about identity? If your memories can be edited, or if your decisions are being influenced by an AI co-pilot living in your head, where do you end and the machine begin? Who's responsible for an action that comes from a hybrid thought? And then there's security, you know? We worry about our phones getting hacked. What happens when it's our brains? We're not just talking about stolen passwords here. We're talking about the terrifying possibility of stolen thoughts, manipulated emotions, or even direct physical control. The old sci-fi trope of brain hacking just became a very real national security threat. And this isn't just some paranoid fantasy. Governments are already waking up to this danger. In September of 2024, California passed a landmark law to protect neural data, basically treating it with the same seriousness as your most private medical records. The risk is that real. And maybe the most disturbing question of all is about equality. This technology, at least at first, is going to be incredibly expensive. So are we on the verge of creating the single greatest divide in human history? Not between the rich and the poor, but a literal biological caste system of the enhanced and the unenhanced. So here we are. We are truly at a turning point. The fusion of human and artificial intelligence, it's not a fantasy anymore. The technology is here, and it is moving at an absolutely dizzying speed. So it really all comes down to this, doesn't it? On one hand, you have the promise of a future without disability, a future where human potential and creativity are totally uncapped. But on the other hand, you have the peril of fractured identities, terrifying new security threats, and a society completely ripped apart by the ultimate inequality. Look, this is not a choice that can be left to a handful of scientists and tech billionaires. The merge is happening. It's beginning. So the only real question left for all of us to answer is this: what kind of future do we want to build with it?